So see here, so next numerical is find the effective capacitance between the points A and B in the following figure. Okay, so here if C1, C3, C4 and C5 is equal to 4 microfarad and C2 is equal to 10 microfarad. Okay, so what they are saying, we need to calculate the effective capacitance between the point A and point B. Okay, see here, so if here A capacitance flows means, and this is connected to the one wire, so that's why, so this is A capacitance, and this is A and this is connected to the another wire, so here also A capacitance flows. Okay, so similarly if this point is C means here this point is C, and if this is B means, so this point is also big B, and this is connected to the one wire, this is also becomes B, and this is D means, so this wire is connected to the this wire, so that's why this point also D. Okay, now so this is in the form of Wheatstone bridge. See, Wheatstone bridge, we will learn this in more about this circuits in third chapter. Okay, so this is in the form of Wheatstone bridge. So in the middle of the circuit we will get another capacitor. Okay, so now see the figure. In between A and C we have C1. Okay, in between A and C we have C1. So I will mark the points A, B, C and D. Okay, in between A and C we have C1. So and in between C and D, in between C and D we have C2. Okay, now in between D and B we have C3, and here C and B, so C and B we have C5. So next A and D, in between A and D we have C4. So in between A and D we have C4. See here, so the circuits become very simple and easy now. Okay, so now the condition for the Wheatstone bridge is, so in the balanced condition, the condition is P by Q is equal to R divided by S. Okay, so this is the point P, Q, R and S. Okay, so this is the condition of Wheatstone bridge, P by Q is equal to R by S. Okay, so at this condition, so it is the condition, so this value becomes 0. Okay, so this is the condition for the Wheatstone bridge. If all the values are same, then this value becomes 0. Okay, so you will learn more about this in current electricity chapter. So now what is the values of C1, C5, C4 and C5? So all the values are 4 only. What it will become? So C4 by 4 is equal to 4 by 4. Right? So now, so these both are in series, right? So these both are in series, and again these both are in series. Okay, so I have replaced the two capacitors with only one capacitors. Here two capacitors with one capacitors. Okay, so now, so what is the formula for in series? So we know that 1 by Cs is equal to 1 by C1 plus 1 by C2. So that is equal to, what is 1 by C1 value? C1, yeah, all are 4 only. 1 by 4 plus 1 by 4. Okay, so 1 by C, and C becomes 2 here. 1 by 4 plus 1 by 4 means it becomes 2. Okay, so similarly 1 by C is equal to 1 by C2 plus 1 by C3 is equal to, this also will get 2 only. Okay, so after this circuit you need to write. So here two combination, it is replaced by the single combination. Its value is 2 and its value is C. Okay, so now, and two capacitors is in parallel now. Okay, parallel means we know that Cp is equal to C1 plus C2. So that is equal to 2 plus 2. So its value is 4 microfarad. Okay, so now, so answer is 4 microfarad. Okay. So see now, next numerical is the potential across the capacitance of 2 microfarad in the figure along with this. Here we need to calculate the potential difference across the capacitance C value, that is 2 microfarad. Here I need to calculate the potential value. So V is equal to question mark along C is equal to 2 microfarad. Okay, see here is, if you observe the circuit diagram here, so 3 microfarad, 6 microfarad and again 3 microfarad are in parallel. Okay, so in parallel we know that Cp is equal to C1 plus C2 plus C3. Okay, so what it will become, so we need to add all the capacitors again, and it is connected to the potential difference or battery. Okay, so here 6 plus 3 plus 3, so here it will become 12 microfarad, and this is 2 microfarad, and again this is same only 70 microfarad. Now it has circuit has simplified into the series combination. In series combination we know that, so CS is equal to C1 C2 divided by C1 plus C2. Okay, so this one is C1, this one is C2, so here 12 into 2 divided by 12 plus 2, so here it will become 24 divided by 14. Okay, so now I need to calculate the V. Okay, in order to calculate V, I will use the equation C is equal to Q divided by V, and V becomes Q divided by C. Again I don't know Q, so in order to calculate Q, so I will use this equation only. Q becomes, so Q becomes C into V. So Q value we got 24 divided by 14 into V value they have given 70 here. So 14 ones are 14 5s are. Okay, see here 24 5s are, so that is 120. So Q is equal becomes 120 microcoulomb. Okay, now substitute here. So V is equal to, what is Q value? We got 120 divided by C value is, I need to calculate across 2. So that's why V is equal to become 60 volt. Okay, so this is the required answer. So see now, next numerical is the equivalent capacitance for the network as shown in the figure. Here they have given the circuit diagram. For this circuit diagram we need to calculate what is the equivalent capacitance. Okay, so see here the capacitor C2 and C3 are in series. So in series we know that 1 by C dash, 1 by C dash is equal to 1 by C2 plus 1 by C3. Okay, so the formula is 1 by C is equal to 1 by C1 plus 1 by C2, but here they have given C2 and C3, that's why I have taken 1 by C2 plus 1 by C3. Okay, so here it will become 1 by C dash is equal to, so C2 and C3 value both are 400 only, it will become 1 by 400 plus 1 by 400, that is equal to, it will become 2 times of 2 divided by 400, so that is 1 by C dash is equal to, here 2 ones are, so 2 2s are, so C dash becomes, so if you take a reciprocal, C dash become 200 picofarad. Okay, so this is C dash value. Now this entire C dash value, we got how much? So 200 picofarad. Okay, so this one is C dash. Now C1 and C dash are in parallel. Okay, so C1 and C dash are in parallel. Okay, for parallel we know that Cp is equal to C1 plus C2, right? For Cp is equal to C1 plus V2. So how it will, what is the value? It will become 100 plus 200, it will become 300 picofarad. Okay, so here, so now this entire circuits we have only, okay, so what is the value we have? So the entire circuits we have only, so 300 picofarad. So another one is, so C4. Okay, so this C4, so C4, and it is connected to the potential, that is 400 volt. Okay, so I have not mentioned the C4 value. C4 value is also 400 only. C4 value is also 400 picofarad. Okay, so now here, so now it looks like this two capacitors are in parallel, but actually the circuit is in like this one. Okay, so the circuit is like this, and it is connected to the battery. So here 400 volt, and this is 300 plus 400. Okay, so this is in series. For series we know that formula, CS is equal to C1 C2 divided by C1 plus C2. You can apply that also, or 1 by C1 plus 1 by C2, that is equal to, what is 1 by C1 value is 1 by 300 plus 1 divided by 400. Okay, so if you take LCM, so how much you will get? 4 3s are 12,000. Okay, so now cross multiply, So 400 plus 300. So you will get 700 divided by 12,000. Okay. So here two zeros get cancelled. So if you take a reciprocal for this one, you will get CS is equal to 1200 divided by 7. Okay. So answer is 1200 divided by 7 pico farad. Okay. So this is the required solution. So see now, next numerical is a capacitor C1 is charged to a potential difference V. The charging battery is then removed and the capacitor is connected to the another uncharged capacitor C2. The final potential difference across the combination is, okay. So here what they are saying, so here they have given a capacitor having the capacitance value C1, okay. So on potential difference is so V and capacitance is C1. So the charging, and then it is removed and the capacitor is connected to the another uncharged capacitor, okay, another uncharged capacitor. So capacity is, another uncharged capacitor is C2, okay, and the final potential difference, here the final potential difference we need to calculate, okay. So initially they are giving a, they are connected to the battery, so that's why it has a charge. So what is the charge value? Q is equal to C1 into V, okay. So now in order to calculate the final potential difference, so we know that C is equal to Q divided by V, right? Here I need to calculate the potential. Now potential becomes, so charge divided by C, okay. So here we need to calculate Q total divided by C total. So that is V is equal to, what is Q total? So Q total we have got only C1 into V only, C1 into V divided by, so C total is C1 plus C2, okay. So now the answer is C1 into V divided by C1 plus C2, okay. So now, so this is the required solution.